Maybe, Karl, we talked about this backstage, but what's the animal on your T-shirt?
This is a bufficorn, a buffalo unicorn, with a nice little ETH logo on the top.
Okay, I have the same shirt as you, and even I did not know that.
Well, yours is even more crazier because it's even more animals, right? There's some
Yeah,
UFOs as well.
yeah, but it's got a kitty.
Interesting. So let's talk about scaling. I know, a big jump of subjects. But are you guys into scaling? Yeah, I guess so. So I looked at the agenda of the meetup tomorrow, the Ethereum meetup, and I like not one, not two, but 3 different keynotes and panels about scaling in one way or another. So it seems like it's like the most important thing on your mind right now, how to scale Ethereum. Let me start with you, Vitalik. From an outsider's point of view, it feels like Ethereum got really popular because it was so versatile. You could do so many things with the protocol. But is it the same reason and the same thing that is causing these scaling issues today, that it is so versatile?
And ultimately, right, like price is a function of supply and demand. And so when transaction fees on any of these blockchains, whether Bitcoin or Ethereum or whatever else, become high, like that can only be, like that basically does mean that there are a lot of people who are sending transactions and who want those transactions to get onto the blockchain. And well, the blockchain is popular enough and people are interested enough in using it that they basically have to compete to get those transactions actually included into the slots and the blocks, right? So.
Yeah. And if you had to design Ethereum from day one today in 2018, would you have made it a bit simpler to make it a bit more scalable from day one?
So there's definitely changes that we know about now that we could have definitely made into the protocol from day one that would have made it significantly more scalable. Though there are also ways in which the problem just is fundamentally hard, and the things that we've learned over the last 2 to 3 years of seeing the Ethereum blockchain live have contributed a lot to our understanding and to like our ideas about how to make blockchains better in the future.
So let's talk about these changes one by one, because it's pretty public, the roadmap and what you've been working on. Justin, maybe you can start by talking about sharding a bit and proof of stake, and give a bit of an overview and explain how the Casper fork would work.
Right, so initially the 2 big initiatives of the foundation from a research perspective were Casper, the proof of stake, and sharding, and these were kind of distinct, and they were going to be launched separately and also be separate designs. The idea of proof of stake is partly to provide a new superpower to blockchains, which is called finality. The other idea of proof of stake is to reduce the cost of consensus. And for sharding, well, that's pretty easy. It's just scaling up. And I guess through the research that has been done in the last few months, we've decided that actually it might be best to combine the 2 in a single design. Partly because there's lots of common infrastructure, and it would make a more seamless design to integrate the 2, a more cleaner design, a simpler design. But it turns out that there's also things that sort of network effects between when you combine the 2. So for example, with sharding, you have all these different shards, and they're like parallel universes, pretty disconnected from each other. And so you want to wait for the shards to be able to communicate with each other, and we do that via what we call crosslinks or checkpoints. And in order for these crosslinks to have a strong value that you can lean upon them, you want these checkpoints to be finalized. And so this is where you get value from Casper. And integrating the 2 means that you're able to do things.
You get both security and scalability, basically.
Right.
Yeah. And so will it require multiple updates, or will you combine everything in one single update, Casper, sharding?
So I guess we're now calling the overall endeavor of Casper and sharding Ethereum 2.0, and this is a very ambitious project, which even though it's a single design, it will likely be rolled over several years. My expectation is that Casper will come first, possibly next year, 2019. And then in sharding, we've actually broken it down into 2 big phases. Phase 1 is actually the data layer, so coming to consensus as to what data is in the shards. And then phase 2 plus is all about the state. It's about giving meaning to that data, having a notion of transaction. And my expectation is that phase 1 can come after Casper, maybe 2020, and then phase 2, 2021 maybe.
So it's still years away, but you're not just working on that, you also have other projects. Karl, maybe we can talk about Raiden and Plasma. So many cryptocurrencies and blockchains are playing around with the idea of creating sidechains, payment networks, and payment channels to offload some of the work outside of the main chain. So Raiden and Plasma are a bit different, but maybe you can give us a bit of an overview. And I'm interested, how would the 2 work together?
Sure. So we just talked about Casper and sharding and how that will kind of give more security and more scalability to the main chain. But those technologies are actually built using like fundamental tools like crypto-economic mechanisms that we've been working on for multiple years. And there are many purposes for these crypto-economic mechanisms, and one of those purposes is actually scaling up dApps as they exist, as scaling up dApps that can exist in today's Ethereum blockchain, right? So you can actually use things like Merkle trees to provide commitments to a large amount of transaction data. So that is actually Plasma. So first, we're talking about Plasma. You basically have the ability to commit to a large number of transactions and not actually send those transactions onto the main chain. Instead, you just provide this crypto-economic commitment, and then later on, you can prove that you own a particular coin by proving that you have received the last transaction in a large chain of transactions. So it allows you to scale up. And then things like Raiden and state channels, you can even have general purpose state channels, are these unanimous consent agreements where everyone's signing messages, and essentially by acknowledging each other's messages, they're able to update state without putting it on the main chain. So essentially the idea is if you use these mechanisms in an intelligent way, it'll allow you to actually provide guarantees about transaction inclusion and provide the services that we want to provide with blockchains without having to wait for the underlying scaling solutions. However, the underlying scaling solutions do allow this to be even easier because you can actually now send, for instance, Plasma requires regular block submission to the main chain. And when we have a main chain that is much more scalable, that means that that block submission is going to be much cheaper. So there are kind of synergies that go along, but the important thing is that these technologies are not holding you back as a decentralized web 3.0 engineer. This is something that you can do today, and that's super exciting.
Is it fair to call Plasma the CryptoKitties update?
You can definitely do CryptoKitties in a way more scalable way. This is like one of the key insights, right? You can make CryptoKitties by deploying a smart contract on the blockchain, and every time you mint a new CryptoKitty, you just send a new transaction and it deploys a new smart contract or something. But you can also do CryptoKitties by deploying just a single transaction or a single hash, which contains a Merkle tree of a whole bunch of CryptoKitties. And then you can breed them by submitting Merkle trees, and you can do interesting, use cryptographic and economic tools to then actually provide scalable CryptoKitties. And that is super exciting.
And Vitalik, I know you've been... Are you excited as well?
Yes.
He's a good seller. I have to give it to him. Vitalik, you've been tweeting about gas prices, and because we're talking about CryptoKitties, what was your reaction, economic reaction, when you saw that the network started to be so congested because of CryptoKitties and because of the massive uptick in Ethereum.
I mean, I think to me it just highlighted that demand for using public blockchains is high, and we basically needs to really step up our game in terms of increasing the scalability in order to be able to meet that demand.
And so, okay, you need to up your game. So let's talk about governance for a minute. Does the Ethereum community have the right structure to pass all these updates?
So
there have been a few updates already. And
so one very important point here is that sharding and Casper are updates, but Plasma is not an update.
Yeah.
State channels and Raiden are not updates, right? No, they're not forks. Plasma and state channels are layer 2 technologies that can be developed on top of the existing Ethereum blockchain as it exists
without
today.
any update, okay.
Yes, and people have already been slowly starting to test and implement state channel and Plasma projects.
Yeah, with like Lightning-style networks and stuff.
Yeah, I mean, there's the Lightning Network on Bitcoin. There was that liquidity Nocust thing that came out a few days ago.
Yeah.
There's Raiden, Funfair did like fake channels, which is their fancy marketing term for state channels.
That's
with
what you
random
tweeted
numbers.
about yesterday, saying that many people are using Plasma as a buzzword for something that is not really Plasma.
Yeah, like there's a lot of people that seem to have the impression that Plasma just means take your centralized server and shove a Merkle tree on top of it.
So
and that's like not what it is.
Magic unicorn technology.
Yes.
Just like a t-shirt, basically.
Yeah.
Cool. But it feels like Bitcoin is a bit stuck in a corner because it's like a cryptocurrency with no head, and they don't have a way to pass some decisions together as a community.
Well, Bitcoin has plenty of heads. You have the core development team, then you have the miners with Bitmain associated pools having 53% of the hash power. Can they agree? No. No, I mean, you have gridlock. And,
Exactly, you have gridlock. And do you think at some point you could face the same kind of issues, the same kind of gridlock?
That very possibly, definitely. So this is part of the reason, right, why I think the Ethereum community very early on has been kind of like both us and other Ethereum developers and people in the community in general have been kind of continuing to kind of promote the idea of like the Ethereum roadmap. And like if I feel like in the eyes of most people in the Ethereum community, like the roadmap is kind of part of the social contract, and that includes the idea that proof of stake will be done, that sharding will be done, that there will be much more efficiency, that there will continue to be upgrades going for some time into the future, and people who buy into Ethereum basically buy in knowing that these are the things that people are going to people are going to want to push forward. And so when people join the community and start building applications on it, they can know that they are doing this on a blockchain and inside of a community that is kind of dedicated to a continuing progress. So there may be deadlock on what specific path the community should take, but I do feel like we've made the very important step of basically committing not to stagnate. And I think for a platform that's still a rapidly evolving technology and a rapidly evolving industry, that's a fairly important commitment to have.
And okay, let's talk in a very pragmatic way. Let's say we are in 2020, sharding, Casper, maybe there is some Plasma technologies that are available around. How will it affect gas price, and how do you think miners are going to react?
So Plasma clearly competes with the Ethereum base chain for transaction inclusion, right? So basically what that means is that application developers have a choice where they can either build their application in a way that uses a lot of base chain transactions, or they can build a Plasma chain and do a lot of Plasma chain transactions. Yeah. So that clearly reduces demand for the base chain, though it increases the demand for transactions that are willing to pay very large amounts to get onto the base chain because they're very important, like the Plasma commitments and Plasma challenges. I mean, I expect in general it'll make gas prices go down very significantly as if we see fairly widespread adoption, and though I expect it'll end up expanding total usage even more.
Okay, interesting. So you talked about plasma and the finality of transaction and how security is important. Maybe Justin, you mentioned security as well. Do you think with the current roadmap you have the right approach when it comes to security to make sure that everything is normal and business as usual?
So from the sharding perspective, the security kind of comes from pooling all the validators in the same place and then randomly sampling the validators and putting them in the shards. From the point of view of Casper, it's actually an extremely simple protocol, and we can just write math proofs about it that are just a few lines long, and they give you strong guarantees about things. So, for example, if you have two inconsistent finalized blocks, then you have a guarantee that at least 1/3 of the validators will get slashed. So that's what we mean by finality. It's actually economic finality in the sense that if something goes wrong, then a lot of money will be burnt.
It can recover by itself, basically.
Right, so that's kind of separate, right? So there's also mechanisms for recovering and mechanisms for making sure that you bad things don't happen in the first place.
So, Karl, when you're working on these new updates and technologies like Plasma, how do you test your code?
This is definitely a difficult kind of process because a lot of this stuff is like very kind of fundamental research, and a lot of it is mathematics that we're trying to basically analyze these protocols, these attack vectors in many different ways. And I think the key thing to kind of ground everything is this adversarial thinking. So we want to create mechanisms that are both efficient, but also that adversaries, people who want to kind of take advantage of other users or do anything wrong that doesn't really do what you want it to do, those people get punished. So we just talked about how 1/3 of all the validators get slashed if they're to do something that we basically don't like. And so that is one example of how even if there is some kind of failure mode that happens, there are consequences for those failure modes. And so that's what we're kind of, what this process of building these protocols looks like is, okay, we think up, what do we want to achieve? What guarantees do we want to provide? How can we penalize people if those guarantees are not provided? How can we reward people who are providing those guarantees? And then once we have this kind of objective, we come up with as much math as possible to describe the scenario. But of course, these are complex systems, and so we also need to simulate them, and the simulation tools are really weak right now. There's a huge space for people creating agent models that kind of simulate different actors, economic actors' decisions, and come up with kind of really complex game trees that we can use to further analyze if there's a missing piece in our actual protocol. But it's basically this iterative process of come up with some good ideas, try to formalize them, simulate it, implement it, realize that we're wrong, go back to our ideas, and repeat and repeat and repeat.
Interesting. Vitalik, do you work with hackers to try to find security holes before pushing an update?
I don't like the word hacker because it implies all of these science fiction connotations that don't actually exist in real life. Yeah, well, we have security audit researchers on our team. We have a bounty program. We get disclosures all the time. Yeah, that's totally all part of the process.
Cool. And let's talk about the foundation for a second. So you have structured this whole community around the Ethereum project. How do you find these people to join your team, basically?
Karl, how have you been found?
Well, I have been found. I found this stuff on the internet watching DevCon 0 YouTube videos. And so Vitalik and Vlad came out with all of these really, really cool, crypto economics videos, and I was just hooked on them. And so I read up everything I could and just kind of contacted Vitalik at a conference and then was like, oh, hey, can I do work for you? And he was like, sure. And then I just started doing work for him. And then, he was like, okay, do this now. And I was like, okay, I'll do that now. And it just kind of snowballed into me working on Casper and sharding and plasma. And so, but now, thankfully, that was the sparse days. Now there's the ETH research where people can kind of look at the research that we're doing. Everything we do is public and put out there in front of the community. There's also cryptoeconomics.study where there's a learning tutorials and stuff like that for learning this kind of cryptoeconomic stuff that I'm working on. And there's hopefully even more videos and presentations, and Justin Drake has an awesome EdCon presentation, for instance, and many more to come. So
You have a lot of energy, I have to say.
oops.
So after having heard that, how many people in this room want to talk to Vitalik and say, hey, I want to work with you? That's my main question. Maybe you shouldn't have said that on stage, because now you're going to get flooded with applications and people coming to your door. Do you guys all agree when you have to take decision? How does it work internally?
Sometimes we agree, sometimes we don't agree, and we both think for a while, and eventually we find something we both like.
So usually there's a third way if you don't like the first way or the second way.
Yeah.
Vitalik is pretty amazing in his ability to actually compromise if he believes something. Justin and I had this moment where we didn't really like Vitalik's sharding design, and we kind of iterated by ourselves for a while, built up our case, and he eventually
Yeah,
said,
and it's been very public. Do you think it's healthy to have these discussions online in front of everyone?
Oh yeah, definitely.
Totally.
How do you look at other blockchains? Do you think there are some implementations that could be interesting and that you could work with to put into the Ethereum project?
There's definitely some that have that are doing a lot of interesting pioneering work in cryptography that we follow closely. I think we've been very close with the Zcash community, for example.
Yeah. And that's the only one.
No, there's others, and we've talked with Dfinity people a couple of times. We've talked with some. There's a couple of other blockchains. We also talk to kind of academic research groups that are not kind of affiliated with any specific blockchain, and we've had close contacts with IC3 for a couple of years, like the Starkware researchers, like people at Stanford.
So, when you all got into this field, did you think you would end up being some kind of researchers? Because maybe you engineers by trade, but now it feels like you're researchers.
Well, I was initially a Bitcoin magazine writer by trade.
Yes. Yeah, that's true.
No, I thought okay, this is a cool idea. I'll just crank out some Python code, implement it for a couple of months, and then go back to university. And somehow that ended up not happening.
Do you still code today, or?
Yeah, totally.
So you're still involved with the main?
Well, I don't really do production code as much. I tend to focus on prototyping because that seems to be where I provide the most marginal value. But
yeah, it feels like it's a different work to work on production code, because you need to put code that is so efficient and easily auditable.
Yeah. And the other thing is production code needs to be written in fast languages, and I like Python.
Something that is very low level. So you're all about Python, basically.
Yeah.
Maybe you should have put a Python on your T-shirt to defend another.
It's a snake.
Interesting. All right, let's talk about other updates in the pipeline. So you mentioned recently Ethereum 2.0, and it feels like a big milestone. But are you already thinking about what's next after that? What would be next?
So we are thinking of Ethereum 3.0 as well.
Okay.
Part of it is reliant on fancy cryptography. Mm-hmm. So one of the things we want to do eventually is have our system be fully quantum secure and minimize the assumptions that we make cryptographically. And one of the best tools for that is called Starks, which are like snarks, but there's no setup, and they're also quantum secure. We're also looking into things like erasure codes to make data availability proofs, and potentially things like super quadratic sharding. But that's still very much research topics.
And do you think, are you hopeful that you're going to push these updates against quantum computing before quantum computing is here?
Yeah.
I think yes, with a very likely with a significant margin. Like quantum secure computing, I think, is actually less hard than a lot of people think. Like basically because you just hash algorithms are all quantum secure, so you just kind of make everything based off of hash functions, and you surprisingly enough, in a lot of cases, you totally can do that.
And I have one last question, because unfortunately we're running out of time. Did you think about opening a t-shirt store to sell your t-shirt designs?
I know other people did, like vitalikwears.com or whatever, but like whatever, let them figure it out.
Okay, so you're letting it
There should be one for
source.
Karl.
Open source designs, basically. Interesting. All right, thank you very much.